Hey, a little tutorial on good old G67 12.2a 2. This is compound probability, the second sheet. All right, quick review. We've got some independent events. Those are events that have nothing to do with one another, like these two spinners. That what happens over here has nothing to do with this. And then you have dependent events, like these problems down here. I'll do one of each. All right, so what is the probability of getting a 4 and a C? Well, if you remember from the first one, we find what is the chances of getting a 4 here. So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 chances of getting a 4. And how many 4s are there? There's only one, so it's a 1 in 8 chance. Now we're just going to multiply that by the probability of getting a C. Well, there's 6 chances here, and there's only one C. So you just multiply straight across. We can't really cross reduce because of the ones on top. So you have a 1 in 48 chance of getting both a 4 and then a C. It's going to increase in this one here because we have more A's here. So let's just take a look at it. So you had a 1 in 8 chance of getting a 1. There's only one there. But there are 3 A's. So we can think of that as 3/6. Or I'm just going to simplify it and say you have a 1/2 chance of getting it. I mean, because half of them are A's. Oops. Here's the other. Here are the 3 A's. So we can multiply straight across. Can't reduce because the 1's on top. And we have a 1/16 chance. So a much, much better chance of getting a 1 and then an A. And that makes sense because there's 3 A's. All right, let's take a look here, and this next one, I'm just going to zoom down a little bit. So these are going to be, turned it the wrong way. These are going to be dependent events because I can see these important words here not replaced. So let's see, there are 10 yellow, 6 green, 9 orange, and 5 red cards in stack. So let's add them up, see how many total cards we've got. 10 plus 6 would be 16. 9 would be 25. Looks like 30 cards in the stack. All right. Once a card is selected, is not replaced, find the probability. So what are the probability of getting 2 yellow cards? All right. We know there's 30 cards. So there are yellow. There's 10 yellows. So we have a 10/30th the chance the first time. Then we're going to multiply that by the probability of getting a second yellow. Now the second yellow is only going to be 29, right? Because we're not putting the card back, so it goes down 1. And we have to go down 1 on the numerator too, because we have to assume that a yellow card has been pulled. So that would only leave 9 left. This is kind of an ugly fraction here. Of course you can use a calculator, but I'm just going to divide by 10 here and call this 1/3 times 9/29. And I'm going to divide by 3 here. That's 1. That's 3. And wow, I've made my life much easier. 1 times 3 is 3. 1 times 29 is 29. 3/29, my friend. All right. How about 6 green? How about number 8 with the 2 greens in a row? So we have 6 greens out of 30. And then the next time there will be 5, and we have to assume that the green is picked. That's why that's a 5. And then, of course, there's 1 less because it's not being replaced, so it's 29. Well, I'm just going to rewrite this. Instead of 6/30, let's just reduce that fraction right away and call this 1/5. All right. Well, we can divide by 5 here, divide by 5 here. We got 1 and 1. Multiply straight across. 1/29 chance of getting 2 greens in a row. All right. Enjoy. I like this stuff.